As you well know, Christmas is just round the corner, so I imagine you're putting the finishing touches to your mince pies, or like me, you're about to run out and try and grab the last turkey.
But this is a wonderful opportunity to put all of that aside, to put your feet up for half an hour as we take a nostalgic look at the best astronomical bits of 2021.
It's the big one.
Welcome to the Sky at Night's Review of the Year.
Well, we've come to the wonderful and surprisingly festive Endeavour Room at the Royal Observatory Greenwich to celebrate 2021. Quite a year for astronomy and space exploration.
The start of the year saw not one, but 3 missions rendezvous with the Red Planet, as we covered in our April programme.
The UAE's HOPE spacecraft will be studying the planet's atmosphere, and China's Shenzhen-1 will be studying its geology. But perhaps the most spectacular entrance was made by NASA's Perseverance rover.
When I first heard about the sky crane, to me it sounded like a James Bond movie, and it sounded complicated, but you pulled it off.
Well, you know, when we were looking for a way of landing it, we settled on the sky crane approach, and we called it the least unacceptable solution. So we didn't like it either. It just was not as bad as any of the other options we had.
As the first pictures started coming through, how did you feel?
We got these images of the sky crane happening from the rover, looking up at the descent stage as it lowers you to the ground, from the descent stage looking down at the rover. So that was mind-blowing for me. The main objective of Perseverance is to take 20 to 40 rock cores from the Martian surface and seal them in phenomenally clean, annoyingly clean, hermetically sealed vessels and return them to Earth with the work of 2 follow-on missions. And so that's a big challenge for us. We got to bring these samples back.
Adam and his team have delivered a beautiful piece of engineering. Another eye-catching aspect of the mission is the striking imagery of the Martian surface that has been pouring in since Perseverance touched down. Here's planetary scientist Brian E. Horgan with an expert's guide to what the 20-megapixel cameras are showing us.
The big goal for this mission is to look for signs of ancient life in these ancient lake sediments, to collect samples and then bring them back to Earth to confirm whether or not life was ever there. That's the reason why we're in Jezero Crater. So here you can actually see the delta that was created when this river flowed through the crater rim. And if we zoom in on the delta, you can see lots and lots of layers, right? And they're not all flat. If we zoom in on this area right here, you can see that these layers are actually tilted. And we think that might have been because they formed in an ancient river channel. Moving to the north away from the delta, you can see this really dark part of the crater floor. This is what we think might be part of that kind of better preserved ancient lava flow that we'll be investigating in the rocks around us. One of the big decisions we have to make, where are we going to go first? We have to get to the delta itself eventually, but we have to decide, do we go north and check out this delta remnant up here, or do we head south and check out another one you can see over here on the far south of this panorama? And so it's a really important decision we have to make here in the upcoming weeks, and we're gathering as much data as we can. Now we're really getting to work, and it's exciting. We have a lot of work ahead of us, for sure.
That programme was just too early for us to report on the first ever flight of an extraterrestrial helicopter, Ingenuity. I've got its images here. Here it is, as seen from the Perseverance rover, the little helicopter Ingenuity. It's rather fun, isn't it?
It is.
There it goes.
Yes. Oh, actually, it just went off the screen.
Yeah, no, it comes back. Don't worry. Hang on. There you go. It flew up, hovered, and came back down. But is this just a gimmick?
No, see, I don't think it is. It's quite interesting because as we have more rovers, we want them to be autonomous, so not controlled from Earth. And things like this, sort of scanning the landscape, I think could be really useful. So it's a first, and it's a bit of a gimmick, but I think it can be useful.
Yeah, they did spend the rest of the year playing with the thing, so it went up and down and sideways. But it's now in operational mode, and it's flying ahead of the rover and helping.
Yes. Thing is, if you had a helicopter on Mars, you'd play with it too.
I mean, that's true. If they give me the controls, I'll do that now. But anyway, turning from Mars to a bit of tech closer to home that helped make a remarkable discovery back in February.
It's entered the atmosphere at about 30,000 miles per hour. A sonic boom was heard by many, and it's fragmented on its way down.
Creating a meteor storm, the meteorite landed in Gloucestershire, mainly on somebody's driveway. What's more remarkable is that its discovery was no accident, but the result of hard work by the UK Fireball Alliance. Luke Daly is one of the scientists involved. Well, Luke, it's lovely to talk to you. It's such an exciting story. Tell us about the network. How many cameras?
There are maybe 6 or 7 networks involved under the umbrella of the UK Fireball Alliance. They use lots of different cameras, from just off-the-shelf CCTV cameras to digital cameras.
By using information from many different cameras, the Fireball's trajectory was plotted. The main landing zone was the town of Winchcombe. And so because of this network, we can connect the point of light in the sky to something that you can hold in your hand. It's pretty special.
Oh, God, yeah. It's amazing, the sort of work that's gone in to generate all these models, to be able to predict where these things would land and then be able to go get them.
The scientist responsible for looking after the precious Winchcombe meteorite and coordinating the research effort is Ashley King.
All of the material that's been recovered so far is safely stored away in these boxes here. So these are desiccators, they're temperature and humidity controlled to try and minimise their contamination with the terrestrial atmosphere.
So we're excited because this is a British meteorite, but how exciting is this in a global context? Are people around the world excited by this?
Yes, it's incredibly rare to get material collected after a meteorite falls so quickly, to get such fresh material. It's even rarer for that to be a carbonaceous chondrite type.
Why is the fact that it's a carbonaceous chondrite so exciting?
These are the most pristine extraterrestrial materials that we can get our hands on. One of the things that we're really interested in using carbonaceous chondrites for is to understand the building blocks of life and why do we have oceans on the Earth? Why did Mars have oceans? And so all that information, simple organic materials, things like amino acids, water-bearing minerals from the birth of our solar system are locked up in this. What's really exciting about this one is that we have that fireball, that camera data. So we have like a pre-atmospheric orbit. We know roughly how big the object was. We have something like 65,000 meteorites in our collections. About 40 of those actually have a pre-atmospheric orbit. And even those people who got things on doorbell cameras and dash cams, that's all really useful for us. And for this one, we know that the orbit goes out somewhere close to Jupiter.
Holding this, knowing that a couple of weeks ago it was in space, is a special moment.
So what's happened to the Winchcombe meteorite?
Well, since we reported, the most important thing is that's now its official name. It has been named after Winchcombe, but they've also started looking at its chemistry. So it's mostly clay with plenty of water, and they've discovered a few % of organic carbon-based compounds, and those will be really exciting when they get to do more experiments. In the meantime, the biggest bit of the meteorite's now on display at the Natural History Museum, right next to the crater. They've taken the bit of driveway that it hit and put that on display as well.
Were they happy with their driveway being removed?
I think once a meteorite hits it, I think you have to donate the whole thing. But it's nice we've got the whole story. We've got the meteorite and the fuss and the impact that it caused, both preserved in the museum.
Having a piece of ancient solar system land on your doorstep is a big bonus. But we're learning huge amounts by sending missions out into space.
In June, we went to the National Space Centre in Leicester, where we caught up with the Juno mission to Jupiter, but also talked about future missions. The European Space Agency's Jupiter's Icy Moon Explorer, or JUICE for short, launches next year, starting its own unique mission, as the project's deputy lead investigator, Emma Bunce, explains.
The JUICE mission is going to be the first European spacecraft to the Jupiter system, first of all, and it's going to be the first spacecraft to actually go into orbit around an icy moon.
So this is an image of part of the Ganymede surface from Juno.
Ganymede is a particular favourite of mine and is Jupiter's largest moon. It's the largest moon in the solar system. It's actually bigger than the planet Mercury.
And I think if you showed this picture to people without context, people would guess this was our moon, right? But we're looking at water ice here, frozen water. That's what the surface is made of.
That's right.
So what's our current guess as to what you'd get if you drilled down through this crust?
Well, first of all, you'd have to drill for quite a long way because it's a very thick icy crust, but we do believe that Ganymede is an ocean-bearing moon, which means that we think it has potentially 100-kilometre deep subsurface ocean underneath the icy crust, which is incredibly exciting.
And that's a water ocean as well.
A water ocean, that's right.
But what comes next after JUICE? What are your grand dreams for exploring Jupiter and its moons?
The way that we have thought about this is that JUICE is the next logical step in terms of our exploration. You know, we've had the Voyager missions, we've had the Galileo mission at Jupiter. Now we're going to have a mission dedicated to orbiting Ganymede and giving us the next level of detail about that moon and its surface and its interior. We need that before we can go any further. So people would like to send landers to the moons of the outer solar system, for example, Europa and Ganymede, but as I'm sure you can imagine, that's extremely challenging. And if you were potentially scoping out landing sites in future, you need to have that information before you can take those exciting next steps.
You know, they've been working on that JUICE mission for so long. Launch is next year, but it'll take them ages to get to Jupiter after that.
Yeah, but that's the way space missions work. You can spend your lifetime, because I mean, it's planning, and then there's actually sort of implementation and building the thing, and then it's got to get to the destination. So they are long-term projects.
Well, I was thinking about this because a big report out in the States just a month or so ago recommended a new space telescope, which sounds amazing. It's going to have a 6.5-meter mirror, be like Hubble, but much bigger, sensitive to the ultraviolet. It's going to do amazing things in the 2040s, if we're lucky. That's a career.
We start planning now.
Well, we need to. This is the thing. Well, one mission that's already up and running made the news back in October. This was ESA's Bepi-Colombo mission to Mercury, which flew past the planet for the first time. Maggie talked to Susie Imber, who, like everyone involved with the project, was hugely excited to see the first images of their target come back.
Yes, that's right. It's a really exciting time for us. Bepi-Colombo actually launched in 2018, so it's had 3 years of its voyage to Mercury already, and it's just flown past Mercury for the first time on the 2nd of October this year. So it's taken 3 years and it's finally flown past Mercury, but that's not the end of its journey, of course. It will fly past Mercury a further 5 times before it finally goes into orbit around the planet.
Yes. And I suppose, is it ever decreasing circles as it gets sort of closer and closer? And then does the orbital insertion?
Exactly right, yes. So we can't launch our spacecraft straight towards the planet Mercury unless we want to do just a single flyby, because it's very difficult for our spacecraft to stop if we want to orbit around Mercury, which is a very small body, very close to the sun. And so you're right, what we do is we launch, we do laps of the sun, gradually decreasing until finally our spacecraft is in the same place as Mercury, traveling at about the same speed. And finally then, of course, with a small final burst, we can end up in orbit around the planet itself.
Fantastic. So how close to the planet did it get in this first flyby?
The first flyby was very close. We got just under 200 kilometres from the surface, which is very close. If you think about this on the scale of satellites orbiting the Earth, the International Space Station is about 400 kilometres above the Earth, and we got to 200 kilometres above Mercury, so extremely close to Mercury's surface. It's the first time that we've seen Mercury with this particular spacecraft, and that's where the excitement lies.
So when you get that sort of orbital insertion, you get that data, what are you hoping to find?
Well, each instrument has different goals. So we have a few goals with the instrument that we built. And our instrument is an X-ray spectrometer, and it's going to look at the surface of the planet. And it was designed to look at the sunlit surface of Mercury. So what happens is that the sun gives off X-rays. Those X-rays hit the surface layer of atoms on the sunlit side and cause those atoms to give off their own X-rays that we then measure. And by measuring the energy of those X-rays, we can work out what those particles were. So our goal is to work out the composition of the planetary surface. And that was what our instrument was designed to do. Several years after all of this was planned and the instrument was designed, and actually when it had been built, we realized there was a second source of X-rays coming from Mercury's surface. And it wasn't coming from the daylit side, it was coming from the night side of Mercury. And after much work, we realized that the source of X-rays was similar, analogous to the Earth's aurora. And so, oh my goodness, we just found a new source of X-rays on Mercury, and they can tell us something about space weather at Mercury. Yeah. And so, having built an instrument looking at X-rays that's designed to do one job, we now have a second job for it to do. And that's why we have so much work to do in the lab, really, is to try to characterize what these X-rays look like and how we can best measure them with our instrument, which really was never designed to make these measurements.
This project is going to be long-lived, so I'm very much looking forward to sort of getting the latest updates as they come in from Mercury. So, Susie, thank you for joining us, and I'm looking forward to speaking to you again.
Thank you so much, Maggie. Pleasure to join you today.
The fun first images, but what happens to Bepi Colombo now?
Well, it's actually going in ever-decreasing orbits because it's going to get closer and closer to the planet, and so we'll get many more pictures. Then the two instruments break free. One's an imager and one's looking at magnetic fields, and so I can't wait till that data comes through.
Yeah, it's going to be fun for Susie and the team, and the rest of us watching as well.
Yes. Bepi Colombo is a joint venture between ESA and JAXA, the Japanese Space Agency. In the summer, we visited Harwell, home to many companies working in the space industry, and another Anglo-Japanese enterprise.
There are now so many useless, dead satellites in low Earth orbit that we could run out of room for new ones. Or worse, debris from crashes might make the entire space untenable. The UK arm of Japanese company Astroscale is testing an experimental satellite which comes with its very own piece of space junk, which it will lose and then learn to recapture.
So this is your test, right?
Yes,
so we
this literally will just come off here,
okay,
and we'll release that into orbit, and then the service will come along and capture it again like that. And then we're going to tumble it, and as that tumbles, we're going to maneuver the service around, because, of course, a real piece of debris will be out of control and tumbling.
And so that's the hard bit. It's sort of tracking and being able to follow the debris around.
Yeah, absolutely. I mean, no one's done that before. When you launch, say, the Progress supply vehicle for the International Space Station, they're exchanging data. You've got humans in the loop. It's very carefully controlled. But a piece of debris, there's going to be no data exchange, so the servicer has to do it all on its own.
It does sound like you're slightly cheating, because you need the thing you're catching to have a magnet. Now, that's fine here, but that won't always be the case.
So what we're lobbying for is that these big constellations going up, like OneWeb and SpaceX with the Starlinks, have a docking plate attached to them, so some mechanism that will allow a servicer to come up and dock with them and deorbit them safely as part of responsible space use.
Well, it's important stuff. We'll wish you luck, and we'll come back and find out how you got on.
It's quite interesting to keep watching Astroscale because the UK Space Agency is funding them to actually try and capture sort of independent satellites. But of course the fragments are such a big problem, and it's going to get worse.
Even in the last few weeks, Russia carried out an anti-satellite missile test. They blew up a large old satellite from the 80s, spreading debris throughout low Earth orbit. Astronauts in the space station had to shelter as this cloud of debris went past. And these thousands of objects are going to be up there for years to come. So it really is becoming cluttered up in low Earth orbit, and we've got to do something about it.
So it's great to see missions like Astroscale, but of course the fragments are such a big problem, and it's going to get worse.
I think it will. Space junk was one of the many topics we discussed with our live studio audience when we visited the British Science Festival in Chelmsford. But Dallas Campbell was rather more taken with a piece of space junk he found outside the theatre bar.
This piece of junk over here, not Chris Lintott, but beyond Chris Lintott, this sort of back of the piano, this actually lives in this theatre. Now, this back of a piano was actually owned by the BBC Radiophonic Workshop, and they were responsible for all kinds of sound effects. Now, what I have here in my hand is a coin. If I rub a coin down the bass strings, you may remember or hear something familiar. It's the TARDIS! It's the TARDIS! This is the actual TARDIS. I think we've got a recording of the TARDIS. So, honestly, do you not think that's amazing? That's totally made my fan. That's the actual TARDIS.
Another thing we learnt in Chelmsford was that Pete was a consultant for the Archers radio programme. Who knew? Here he is from that show, telling us what to look out for in the night sky in 2022.
While we've got you, Pete, and we're going to give our panel here just a small little pause while you tell us the kind of things that everyday farming folk should be watching out for over Ambridge in the next year, if you could.
OK, what have we got to look forward to in 2022? Well, the year starts off with a bang with another meteor shower, the quadrantid meteor shower. Now, not many people go out and observe this shower because, well, I think it's because everybody's got other things on their minds after the holiday break. But it peaks on the night of the 3rd of January into the morning of the 4th, and it's a really active shower, so it's well worth going out to have a look at if it's clear. Okay. On the 16th of May, so we're jumping forward a bit into the year now, we've got a total eclipse of the moon. Now this one's going to test us because the moon slips into totality just before it sets, which is a bit of a problem because it is quite difficult to see a fully eclipsed moon against a bright dawn sky, but it should be quite interesting anyway. Now as we move further into the summer, we've got the planet Uranus, which will be occulted by the moon, and that occurs on the 14th of September. Now, the moon is a big, bright object in the sky, but actually it's not that big. If you hold your little finger up at arm's length, that'll easily cover it. It covers faint stars fairly frequently, and it covers bright stars relatively infrequently. But covering planets is pretty uncommon, so this is a big event to look out for. Then, as we go through into the back end of September, we've got another event involving an object covering another object, and this time it's the moon covering part of the sun. So we have a partial solar eclipse, and that will occur late morning, so it'll be really well timed for the UK. Now, as we go through into the end of 2022, there will be a really bright planet appearing, bright and orange in colour, and that can only be one thing. That's the planet Mars. Now, Mars doesn't come to opposition every year. It takes 2.1 years between oppositions. So they're a big deal when Mars comes to opposition. The one on the 8th of December 2022 is particularly good for us here in the UK because it'll be really high up. But as luck would have it, the moon is also going to move in front of Mars. And that's going to be an amazing sight if it remains clear. That happens on the morning of opposition day. So those are a lot of things to look out for from now through to the end of 2022.
Now, we're used to looking at the night sky with binoculars or maybe even a telescope, but very rarely with a TV camera. And so I was pretty surprised when I was watching the Cricket World Cup at the end of October and something distinctly un-cricket-like appeared on screen. We got this shot here.
That's Jupiter and moons as well.
Jupiter and moons, yes, suddenly in the middle of the coverage. It was thanks to a new zoom lens that was being used to keep track of the cricket ball. Turns out has use for celestial photography, and we saw it thanks to this guy, Taki Raza, who was the cameraman who got distracted by the beauty of the night sky in the middle of the game.
Well, it shows that cricket is wonderful, but the night sky has that draw.
I think we can have both. Yeah.
From the latest tech to something old school. In November, Pete and Chris went to Hurst-Monceau, former home of the Royal Observatory.
In 1946, the Royal Observatory left Greenwich in a bid to escape the increasingly polluted London skies. Its new home was located 10 miles inland from Eastbourne, officially the middle of nowhere, East Sussex. Hurst-Monceau Castle initially provided accommodation for the Royal Observatory's staff, whilst the observing would take place from a series of new domes designed by architect Brian O'Rourke.
O'Rourke had a background in the interior design of passenger ships in the 1930s, the golden age of the ocean liner. And you can see that coming out in some of the detail in the buildings behind me.
What O'Rourke achieved here is that rare thing, a technical facility which is also aesthetically pleasing. But the Royal Observatory's stay at Hurst-Monceau was short-lived. Ending in 1990, its funding diverted into international collaborations, such as the soon-to-be-launched James Webb Space Telescope. Chris spoke to Paul Eccleston, chief engineer of its MIRI instrument, made here in the UK.
Well, thanks for coming to see us. In all the history of telescopes, there's never been one that looked like this.
Yes, it has this massive sun shield that's going to protect it from any stray light from the sun and the Earth. And that's also going to allow us to get the telescope really cold because it's operating in the infrared.
So that's the mirror sitting on top there.
Yeah, so at the top here you see the primary mirror, which collects all the light. It's got a massive collecting area that's something like 20 times the size of the Hubble telescope. That then reflects the light back to where this secondary mirror deploys out here, comes back in through the middle missing segment, and then into the instrument module behind, which is where the cameras are housed.
So tell us about the instruments on board, and particularly MIRI, which I know you've been involved in.
Yes. So in here we have 4 different instruments. There's 2 cameras that are working in the near-infrared. Then we have a near-infrared spectrometer, NIRSpec, that was built out in Germany. And then finally the MIRI instrument, that's the mid-infrared imager and spectrometer, that was built and assembled by a team from around Europe and the US and assembled here in the UK.
What were the biggest challenges, particularly with MIRI?
So for the instrument, the biggest challenge is how cold it has to be. We operate it down at 6 Kelvin, so even colder than the rest of the spacecraft, because it needs to be as cold as it possibly can be to get the detectors as sensitive as they need to be to see those very early galaxies in the universe.
And this is why that sensitivity, that desire to be cold, is also why the spacecraft's going to where it's going. It's not in orbit around the Earth like Hubble is.
No, it's not. So it's going out to well beyond the orbit of the Moon, a place called the L2 Lagrange point, 1.5 million kilometres away. If it was in orbit around the Earth, you'd never be able to get anywhere near as cold as we need to.
I'm really excited because I worked on the James Webb Space Telescope on 2 instruments, and it is due to be launched virtually imminently.
Well, let's hope so. As we speak, the big day is December the 22nd. It's been delayed just a few days more because of a recent problem. There was a clamp let go, which sounds scary, and the telescope vibrated in an unexpected way. So they're just checking all is well. But hopefully, James Webb will be up. And then the terrifying bit begins, because the mirrors have to unfurl, the instruments have to align. There are 340 separate things that have to go right for this telescope to work. It's going to be a long 6 months watching all of that happen, I have to say.
I'm confident that it will work. It's been tested to almost within its life. And I think that's one of the reasons that's caused the delays. But at the same time, there's a lot that could go wrong. But I'm sort of scarily optimistic.
Well, I hope you're right. I hope we're sitting here next year talking about the first images and the first science from James Webb. But there are other launches to look forward to as well. We've got ESA's Franklin rover going to Mars. We've got JUICE heading off for Jupiter. And I'm really excited to see the launch of Psyche going to an asteroid Psyche, which we think is the core of a failed planet. It's going to be a fascinating mission.
I love that. But actually, the thing I'm most looking forward to, and I've been looking forward to it for a long time now, is the first UK spaceport. And they keep on promising, and they said it's definitely going to be 2022. And I'm optimistic, but I'm slightly worried it's going to slip again.
Well, we'll see. We'll catch up next year and see whether your optimism is well-founded or not. Now, that's all we've got time for, but we're going to end this programme in a very unusual way. For the first time, we're going to use a piece of music called The Sky at Night, written by one of the founding members of the band Yes, Peter Banks, who was inspired by this programme. He recorded it with his band Empire in 1974. Apparently, he sent it to Patrick, who just wrote back and said he didn't understand rock music, which I have to say does sound like him.
We'll be back next year. But in the meantime, from all of us at The Sky at Night for 2021, good night.
Life gave us mystery to be solved, to question why. He gave us the sky at night.
Nice jumper.
Thanks.
Ho, ho, ho.